Hello friends, in this part of the video for Differentiation-1 chapter, we will discuss some more examples of continuity and differentiability. We already have two previous videos on the same topic. In the first video, we discussed the very simple problems of continuity and differentiability. The second problem, we discussed some graphical approaches to continuity and differentiability. In this part of the video, we will focus on some mathematical tricks where you can through which you can solve problems related to continuity and differentiability. So in the last video, we discussed that there are problems where you can just directly sketch the graph and understand the differentiability and continuity using seeing breaks or smoothness of the curve. But what if there is no problem like that? So for instance, let us say you get a problem like this, which is very hard to sketch. So the function says x square sine 1 by x for x not equal to 0 and 0 for x equal to 0. So the function is fx something like this. Now how do we even start sketching this? This is very difficult to sketch, obviously, because sine 1 by x, so and when it will approach 0, it will become sine infinity. Something like this is very difficult to sketch in general. However, you can still try to find the continuity and differentiability of such a function. So what the question says, discuss the continuity and differentiability at x is equal to 0. Discuss the continuity and differentiability at x is equal to 0. So how can we start the problem? How can we even think about the problem? So in problems where you get something as straightforward or questions just like this where you cannot sketch, you just have to resort to the basic definitions of LHD and RHD. We know that the function is differentiable when left hand derivative is the same as right hand derivative. Hence, we will just directly write the value of left hand derivative and right hand derivative. So left hand derivative is limit h tends to 0 f of 0 minus h minus f of 0 by minus h. We have discussed this before, and if you have forgotten this, I recommend you to look at the video. So let us find f of minus h. So f of minus h, we will use this definition, which is minus h whole square sine of 1 by minus h minus f of 0. F of 0 is nothing but 0 divided by minus h. Now if we evaluate this further, basically this becomes minus h sine of 1 by minus h and limit h tends to 0. Now here if we put the value of h equal to 0, approaching 0, this becomes minus infinity. So this becomes nothing but minus h sine of minus infinity. Now this value sine of minus infinity is an oscillating limit, that is we don't know what infinity will be like. We don't know whether it will be minus 1, 1, 0, but it will definitely be between minus 1 and 1. And if I multiply something finite like between minus 1 to 1 with h, we know that this will be nothing but it will still approach to 0. This will approach 0. So this means left hand derivative is 0. What about right hand derivative? Right hand derivative is something similar, however it has 0 plus h minus f of 0 by h, and if you again put the same thing, then this will become h square sine of 1 by h minus 0 by h, which is nothing but h sine 1 by h, and because it is 1 by h, this will become h sine infinity, and similarly this will also approach to 0. So I mean this is exactly the same as minus 1, just that this is plus infinity and minus infinity doesn't matter, because even plus infinity will oscillate between minus 1 to 1. So LHD and RHD are same. LHD is equal to RHD, which means function is differentiable, and because it is differentiable, it is also continuous. Okay, it is differentiable as well as continuous. So I hope you understand that you may get problems which are just like, you might just have to directly evaluate LHD and RHD and see whether the function is differentiable or not. Alright, so let us do one more problem on the same topic. The function fx is x sine log of x square for x not equal to 0 and 0 for x equal to 0, and you have been asked to do the same thing, discuss the differentiability and continuity at x is equal to 0. Okay. So if you see a problem like this, again we cannot sketch the graph. It is not a polynomial sin x cos x type thing, so we are not able to sketch something like this. So what we can do is we can find the LHD and RHD directly. So let us try to find LHD first. Limit h tends to 0 and we put f of minus h, 0 minus h minus f of 0 by minus h. This will become minus h sine log of h square, because minus h square is h square by minus h, and this is nothing but sine log of h square. Now what do we do, because there is no, this now becomes basically sine of, if we put the value log of 0 approaching 0 is minus infinity, so this becomes sine of minus infinity, and this means that this is an oscillating limit. So this is not oscillating limit multiplied by h, this is just oscillating limit, because we know that a very negative number sine will still always oscillate between minus 1 to 1. So this means that LHD is an oscillating limit, or in other words we cannot really define LHD by a single number, and if we do right hand derivative, even if it comes out to be something, we cannot really equate an oscillating limit to anything. Even if RHDs we know that will become between minus 1 to 1, there are oscillating limits and we cannot say that this is an exact value of LHD, and hence whenever you see something like an oscillating limit for even one of LHD and RHD, we have to say that function is not differentiable. Function is not differentiable. Now, if the function is not differentiable, does this mean that it is not continuous? No, that is not true, because we have discussed previously that whenever the function is differentiable, it means it is continuous. However, whenever it is not differentiable, it may or may not be continuous. So it may still be continuous. So for that we have to find the left hand limit and right hand limit. Let us now find left hand limit. So left hand limit is nothing but f of minus h, because where limit h tends to 0, and we have already evaluated that, that is nothing but minus h sine log of h square, and if we do that, that is something sine of minus infinity, and we have already discussed that this will come out to be, this will oscillate between minus 1 to 1, or this will become to be 0. Similarly, you can yourself check that RHL is also equal to 0, because it will be just similar, just it will be plus h here rather than minus h, but rest of the things will remain the same. So and also LHL is equal to RHL is equal to function value at f equal to 0, and hence it is continuous. So this is also a nice example to show you that even though the function is continuous, it is not differentiable, or if the function is not differentiable, it may still be continuous. So whenever you see problems like this, you have to resort to the basic definition of LHD and RHD, and these are very nice problems to practice. You can find more problems, similar problems to practice. I do believe that this is an important part for JEE preparation, to learn to solve problems like this. I hope this video was useful. Please check out more videos. In the next part of the videos, we will start discussing the derivatives from first principle and and then there are many more videos for the same chapter. I hope you enjoyed the video. Thank you.